Today we're going to take systems of equations one step further and look at systems of inequalities. So in a system of inequalities, there are multiple solutions for almost every system. Your solution will actually look like a colored section of a graph, and all the points that are in that section are solutions. So we'll have to do all of these by using graphs. First, we'll graph the first inequality and shade in one color or in that one direction, and then we'll graph the second inequality and shade in with a different color or in that different direction. And then the section of the graph that has both colors or lines in both directions is where the solutions will lie. So we'll have graphs that maybe look like this. So you'll see here that in this first one we have this red section, which everything was above this dotted line and was up, and then we had the solid line over here. Things were shaded to the left here in yellow, and then what they had in common was this area right here in orange, and that is the solution set that we're actually going to care about. So it's what overlaps is what counts. Alright, over here we had the solid line, and we looked at the solution space that was above that solid line in blue, and there's a dotted one right here, and we shaded above that as well in red, and then you can see this overlap right here. That's basically kind of like a purplish color, and that's the solution set that counts. So that just this blue space down here isn't going to do it for us. It's just going to be what they have in common, or what overlaps. It's also possible for there to be no solution. So you can see here that we have two solid lines. This one has some shading in blue below it. This one has some shading in yellow above it. There's no overlap here, so there's no solution. Alright, let's look at some examples together. First we have y is greater than 2x minus 1, so we'll graph that one first. The y-intercept is at -1, the slope here is 2, so we'll go up 2 and over 1, up 2 and over 1, up 2 and over 1. This is a greater than symbol, so we're going to have a dashed line. Don't forget about that. Alright, and then it's greater than, so we're going to be shading above. Let's look at y is greater than or equal to -x plus 4. So we'll start on the y-intercept here at +4. The slope is -1 or -1 over 1, so we'll go down 1 and over 1. Down 1 and over 1, down 1 and over 1, down 1 and over 1. So it's going to be a solid line, and we will be shading above since it's greater than. Okay, and you can see the region they both have in common is this region right here. And that region is going to be our solution set. Alright, let's look at another. Here we start off with y is greater than -8x minus 6. So we'll start on the y-axis at -6. Slope here is -8 or -8 over 1. So we can't go down 8, but we could go up 8. And then go left 1. Could do that again. Very steep slope here, but it needs to be negative, so always make sure you check and make sure that it's negative when you draw your line. Our line here is going to be dashed, and then we need to shade above. Since it's greater than, we'll be shading above. Alright, and then the next one, I'll do it in purple, is y is less than 2x plus 4, so we'll start at +4 on the y-axis. Up 2 over 1 and up 2 over 1, since the slope is 2 or 2 over 1. This again is going to be a dashed line, and this time it's a less than symbol, so we're going to be shading below. Alright, the overlap here is much larger than the last graph. The overlap is everything that I'm shading in this dark purple here. It's this entire region here. So once again, where they overlap, or that common overlap space, there is going to be our solution set, and any point within that shaded area is going to be a solution to the system of inequalities.